Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today we'll start with chapter 3, differentiation. We'll start with section 3.1 with the title of tangents and the derivative at a point. In chapter 2, we did study the rate of change and the limit of the rate of change as h goes to 0. Here we are going to use almost the same definition, which says the slope of the curve y equals f of x at the point P of the coordinates x0, f of x0 is the number, m equals the limit of f of x0 plus h minus f of x0 divided by h as h goes to 0, provided that this limit exists. So we said m here is the slope of the curve of the function, or is the slope of the tangent line to the curve at the point P. We did learn this in chapter 2, and we did solve some questions on this definition of the slope of the curve, or the slope of the tangent line to the curve. Let's see again this example. Example 1, find the slope of the curve y equals 1 over x at any point x equals a, which is not equivalent to 0. What is the slope at the point x equals minus 1? Where does the slope equal minus 1 over 4? So here we have a function y equals 1 over x, and we want to find the slope of the curve of this function at x equals a. A is unknown, any constant a, provided that a is not equivalent to 0. And then we have to answer this question: what is the slope at the point x equals minus 1? Means if we assume that a equals minus 1, what will be the slope? And then in part B, where does the slope equal minus 1 over 4? We have to find the value of x at which the slope equals to minus 1 over 4. Now, this is the graph of the function. You can see in the blue colored line. It's two sections, because the graph to the right is for the interval of the domain from 0 to infinity, and the graph to the left is for the values of x from minus infinity to 0. We understand that this function is discontinuous at x equals 0, because the limits from both sides are not the same. Anyway, so let's find the slope of this curve of this function as x goes to a. So we have to follow the definition. This is the definition for the slope. The limit of f of x0 plus h. So now x0 is a, minus f of x0, that is f of a, divided by h. We have to find this limit as h goes to 0. I use this definition of the limit. Now x0 is a, the point where we're finding the limit at. So this point is assumed to be a, x equals a. So x0 will be in the definition equals to a. So we substitute x0 by a in the definition. Now f of x plus h means I have to go back to this function 1 over x and substitute x by a plus h. You can see here 1 over a plus h minus f of a. F of a will be, instead of x, a, 1 over a, divided by h. So I have to solve this, find this limit. So what we do here is we just subtract these two fractions, divide by h, and we will get this simple fraction. Now if you expand this bracket, then a minus a will be 0, and then we will have minus h in the numerator. In the denominator we have h multiplied by a and multiplied by a bracket of a plus h. Now if we cancel h with h, then we will have in the numerator minus 1, in the denominator we have this term. Now by direct substitution we will get the answer, which is minus 1 over a squared. So the limit here will be in terms of a, because a is unknown to us. So this is the limit of the function, or the limit of this definition, which is the slope of the curve of this function. Now, if x equals to -1, because we need to find the slope if a equals -1, then we have to substitute a by -1. We will get -1 divided by -1 squared, that is -1. So here, the slope at x equals -1 will be -1. Okay, and you can see here in the graph, the blue colored line, the red colored line is the tangent line at the point A, and at x equals -1, this is the tangent line, and the slope will be -1. So for this line at x equals A, because A is unknown to us, let's say it's a positive number, arbitrary value, so the slope will be -1 over A squared. If A is equivalent to -1, then the line or the tangent line will be here, and the slope is -1. Now the second part of the question is says, where does the slope equal -1 over 4? So we have to make this slope equivalent to -1 over 4 and evaluate the value of A, which is the value of x. So if you make -1 over A squared equals -1 over 4, and you solve this equation, then you will get A equals either 2 or -2, positive 2 or -2, which means that there are 2 points at which the slope equals to -1 over 4. The first point is when x equals 2, and the second point is when x equals -2. You can see these two lines parallel to each other, which means that they have the same value of slope, that is -1 over 4. Okay, so this is the first point with the coordinates is 2.5, and this is the second point with the coordinates of -2 and -1/2. At each of these 2 points, the slope of the tangent line is -1 over 4. So this is the way we determine the slope of the tangent line of the function. Now the other derivative, which is related to the previous one, is the derivative, the other definition, which is related to the previous definition, is the derivative of a function f at a point x0, denoted by f prime x0. See this notation, we write f. Here we have on the top, we have prime, a small comma. So this we read it prime, okay? So we read it f prime x0. F prime x0 means the derivative of the function at x equals x0. So this derivative of the function at x0 is exactly the same definition as the slope of the tangent line to the curve at x equals x0. Okay? So hence, this definition, which you see here, of the limit of f of x0 plus h minus f of x0 divided by h as h goes to 0, we can call it either the slope of the graph of y equals f of x at x equals x0, or we can call it the slope of the tangent line to the curve y equals f of x at x equals 0, or we can call it the rate of change of f of x with respect to x at x equals x0, or number 4, the derivative f prime or f prime x0 at a point x equals x0. Just let me go back to number 3. This is the rate of a change. It's not the average rate of a change. Okay, the term inside the limit is the average rate of a change. If we consider, or if you calculate the limit of this average rate of a change, we will call it actually the instantaneous rate of a change, or shortly the rate of a change. So the rate of a change is the limit of the average rate of a change. So this definition has actually 4 names, either name number 1 or 2 or 3 or 4, depends on the question. Sometimes the question will ask you to find the slope of the graph of the function, or the slope of the tangent line to the curve of the function, or the rate of a change of the function, or the derivative of the function. Okay, so in this section we'll be, or in the coming section, section 2, we'll be using only the last one, which is find the derivative of the function. So if the question is asking you to find the derivative of the function f of x at x equals x0, it means that asking you to find this limit in the definition. So let's see some exercises in your textbook. Here we have find an equation for the tangent to the curve at the given point, then sketch the curve and tangent together. Okay. In the second set of equations, find the slope of the function's graph at the given point, then find an equation for the line tangent to the graph there. Okay, almost the same. Okay, see, the first one is asking to find an equation of the tangent line. You can find the equation of the tangent line if you first find the slope of the tangent line. In the second set of the question, you need to find the slope of the function's graph, which is the tangent line, and then you find the equation. In the last set of questions, find the slope of the curve at the point indicated here. So you find the slope, okay? All of them will be using the same method, which is finding the limit of the function, which is in the previous definition. So let me solve to you now, show you the solution of one of these equations. Let me start with question number 5. Let's say if we want to find the equation of the tangent line, so first we have to find the slope of the tangent line. So we will say the point here is x minus 1 and y3, means these are the values of x0 in the definition, which is minus 1, and y0, which in fact equivalent to f of x0, means the value of the function at x equals x0, which is minus 1. If it's not given in the question, you can find it. You have to substitute here x by minus 1, and then you will get this value of y0 or f of x0, which is 3. Now we'll go back to the definition and we'll say the slope equals the limit of, as h goes to 0, of what? Of f of x0 plus h minus f of x0 divided by h. So f of x0 is 3, but how about f of x0 plus h? We have to find it first, okay? So here we have to find f of x0 plus h. Now, which is f of 1, because x0 is minus 1 plus h. So we have to substitute in the function x by minus 1 plus h. Where is the function? Again, this is the function. So we have to substitute x by minus 1 plus h, and we have in the function, sorry, we are talking about this function number 5, 4 minus x squared, okay? 4 minus x squared. Okay, so the function is 4 minus x squared, so I have to substitute here 4 minus, instead of x squared is minus 1 plus h. Okay, now we have to expand these brackets, so 4 minus, this is square, right? Okay, so it's 1 minus 2h plus h squared, because this is a complete square, the square of the first term plus 2 times the first term times the second term plus the second term square. And then you have to expand again, 4 minus 1 plus 2h minus h squared. So in the simple form, this will be 3 plus 2h minus h squared. So this is f of x0 plus h. So we have to go back to the definition and say m equals to the limit as h goes to 0, and then we have to make the substitution 3 plus 2h minus h squared. This is for the first term in the definition, minus f of x0, we said it's 3, okay, divided by h. See, 3 minus 3 is 0, and then lim as h goes to 0, we have to keep writing the lim, this term, okay, because we did not evaluate the limit yet. So 3 will be cancelled with 3, and then we will take the common factor h, open bracket will be 2 minus h divided by h. H will be cancelled with h, and with that direct substitution now, the final answer, we don't have to write the limit because we will evaluate the limit. So put instead of h 0, then the answer will be 2. So for this function, at x equals minus 1, the slope will be 2. We found it as 2. Okay? So this is the slope. Now the second part of the question is find an equation for the tangent line to the curve at this point. So we need to find the equation. So the equation will be found by using this formula. M equals y minus y0 divided by x minus x0. And then we will say M equals 2. So 2 divided by 1 equals y minus y0, that is 3, because here y0 is f of x0, 3 divided by x minus x0 is minus 1. So here you simplify this, you will get y minus 3 equals 2 multiplied by x plus 1. Here minus 1 becomes plus 1. So y minus 3 equals 2x plus 2, and then we can say y equals 2x plus 5. So this is the final answer. Y equals 2x plus 5. You have to notice that this is the slope-intercept form of the linear equation, and the tangent line is having a linear equation, so the coefficient of x should be the same as the slope here, which you found, 2x. Okay, so this is the way we find the slope of the tangent line and the equation of the tangent line. So you can do the same thing for the rest of the questions, okay? Yeah, that's it for today. Bye-bye. Assalamu alaikum.